This is our second video on polynomial inequalities, and in this video we'll solve the inequality of x minus 1 times 2 minus x times x plus 4 bigger or equal to 0. And we're going to build on our previous video's knowledge, where we solved a quadratic inequality using a number line. So here we can see that we do not have a quadratic equation as before, but this equation would rather be cubic. Notice that we do not need to factorize, so we can simply use the brackets in order to find the critical values. So if I set the first bracket equal to 0, x would be equal to 1. If I set the second bracket equal to 0, then x would be equal to 2. And if I set the third bracket equal to 0, then x would be equal to negative 4. So these are my critical values: x equal to 1, x equal to 2, and x equal to negative 4. And what I'll do next is plot these values on a number line, where the number line represents the x-axis. And what we want to do is determine where on the number line would the equation be positive or negative. So in order to find that value, I would replace x with a number after 2. So I'm going to consider 3. So if I substitute x with 3, I have 3 minus 1 times 2 minus 3 times 3 plus 4. And that is equal to negative 14. So what I learned from that is when x is equal to 3, meaning a number after 2, then the equation would be negative because it produced a negative 14. Then it will follow a pattern of negative, positive, negative, positive. Now you don't need to know anything about a cubic function in order to interpret this inequality. Simply put, what the critical values is where the graph would intersect with the x-axis. And we see that the value after the x-axis, that function would be negative or below the x-axis. And between 1 and 2, the function would be positive. That's why the sign changes from negative to positive. And then this is another intercept with the x-axis. So afterwards, the graph would be negative again. And then it intersects again at negative 4 and the graph would be positive. But for the purpose of inequalities, you do not need to worry about the shape of the function. Rather, where is it negative and where is it positive? Now we can use these signs to interpret the inequality and answer where is the function bigger or equal to 0. And that is everywhere where the x would be positive. So we can see that the x values must be smaller or equal to 2 and bigger and equal to 1. So between 1 and 2. And x must also be towards the left of negative 4. So x must be smaller or equal to negative 4.